Okay, so this is going to be a quick video on some of the physical properties of alcohols. Pretty much all of this information is review of Chem 1212 and also things we did at the beginning of Orgo 1, but I thought it would be good to remind us of some of these concepts. All right, so the OH group in alcohols has a profound effect on its physical properties. Right, if we compare the boiling points of ethane, chloroethane, and ethanol, we can see the boiling points get significantly higher as I go from ethane to chloroethane to ethanol. Right, and this has to do with the intermolecular forces. Right, ethane is nonpolar. It only has carbon-carbon and carbon-hydrogen bonds, so it only has dispersion forces, so it has a relatively low boiling point. Right, when we add a chlorine, this molecule has a dipole moment, so the interactions between two chloroethane molecules are going to be dipole-dipole interactions, which is stronger than the dispersion forces in ethane, and so it has a somewhat higher boiling point. Right, and then when we go to ethanol, now I have a hydrogen directly connected to an oxygen, so the strongest intermolecular forces in ethanol are going to be hydrogen bonding, and so that increases the boiling point even more. Right, so a lot of the physical properties of alcohols are due to the presence of hydrogen bonding, and in this case it gives it significantly higher boiling points than similarly sized compounds that can't partake in hydrogen bonding. Right, also, when we're talking about boiling points, as is generally the case, right, as the size of the alcohol molecules increases, the boiling point also increases because of increased dispersion forces. Right, and we can see that in this example. Right, I have ethanol and one nonenol, which both have an OH group, and so it can undergo hydrogen bonding. Right, but one nonenol is much bigger. So when we take two nonenols and put them together, we're going to get lots of surface area between those two molecules, which is going to have much higher dispersion forces than what we'd have in the ethanol, and so that's going to increase the boiling point. Right? If we have similar intermolecular forces, or similar types of intermolecular forces, right, the bigger the molecule in general is going to have stronger intermolecular forces due to dispersion, and it's going to have the higher boiling point. Another property of compounds that we're often interested in is how soluble they are in water. And so in alcohols, the presence of this OH group, this hydrophilic region, is going to make them readily mix with water. And so for alcohols with 3 or less carbons, they are in fact miscible with water. Miscible means that we can mix them in any proportions and still get a homogeneous mixture. So methanol, ethanol, propanol, they are very soluble in water. I can mix them in any proportions and I'll get a homogeneous solution. Right? But when the alcohols start to get larger, they do not readily mix with water. Right? When we talked about polar and nonpolar in Gen Chem, it was often very black and white. Right? But as I'm sure you've seen in organic chemistry, when we get these really large molecules, right, there's more of a gray area. Right? And so yes, these big alcohols have a hydrophilic region, but they also have a very significant hydrophobic region. And so when we get to alcohols with more than 3 carbons, right, the hydrophobic region starts to kind of take over when we try to mix these with water. And so these big alcohols do not readily mix with water. And so they have very low solubilities in water. All right, so I like this table that I've taken from another textbook, but it kind of sums up a lot of the things that we've talked about in this video. Right, so when we have alcohols, as they get larger, right, that tends to increase their boiling points because when we have bigger molecules, the dispersion forces between those molecules are going to increase, giving them stronger intermolecular forces and higher boiling points. Right? As we go from smaller alcohols to larger alcohols, the solubility in water decreases, right? Because as we get more significant hydrophobic regions, it's then no longer able to compensate, or it sort of takes over for the polar region, and so it tends to dominate the properties. And so for methanol and ethanol and propanol, those are soluble in water. Butanol is only slightly soluble, right? And we get anything bigger than that, and they're not going to mix. They're going to form heterogeneous mixtures.